For decades, rockets have been our only ticket to space, powerful but costly and inefficient. Imagine a new way launching satellites not with fire but with a giant spinning arm, a centrifuge that hurls payloads skyward. This was SpinLaunch's radical vision, a ground-based slingshot to orbit using clean electric power instead of tons of fuel. The promise? Dramatically lower launch costs, faster turnaround, and a future where space access is routine. SpinLaunch aimed to democratize space, making launches affordable for startups, universities, and nations worldwide. Founded by Jonathan Yaney, the company set out to turn this sci-fi idea into reality, envisioning constellations of satellites for global internet and climate monitoring. The traditional rocket, with its high costs and environmental impact, suddenly looked outdated next to this bold, kinetic approach. The stage was set for a new chapter in the space race, one powered by ingenuity, not just fuel. So, how does a centrifuge launch work? Picture spinning a bucket of water. Now scale that up to a 100-meter vacuum chamber. SpinLaunch's system used a massive rotating arm inside a vacuum to minimize friction, spinning a payload to hypersonic speeds. At the perfect moment, the arm released the launch vehicle, shooting it up a launch tube and into the sky at Mach 6. This cosmic slingshot replaced the most fuel-intensive part of launch with pure kinetic energy. But the journey wasn't over. Once above the thickest atmosphere, a small rocket on the payload fired, pushing it into orbit. The challenge? Surviving the brutal G-forces, up to 10,000 times Earth's gravity. SpinLaunch had to redesign satellites from the ground up, creating ruggedized models tough enough for the ride. Every component, from electronics to antennas, was reimagined for this new era. It was a complete rethinking of how we send things to space. Vision is one thing, proving it works is another. At Spaceport America, SpinLaunch built a 33-meter suborbital accelerator, a 1/3 scale prototype. In 2021, they flung a 10-foot projectile thousands of feet skyward. No rocket fuel required. Success. The physics worked, and the hardware survived. Over 10 test flights, they refined the system, perfecting the split-second release and studying flight dynamics. By 2022, payloads with cameras for NASA reached 25,000 feet, capturing stunning footage and proving internal components could survive. By 2023, suborbital testing was complete. The focus shifted to building the full-scale 100-meter orbital accelerator at a coastal site. With $150 million in funding and ruggedized satellite designs underway, SpinLaunch seemed poised to revolutionize space by 2026. The dream felt within reach. But as SpinLaunch celebrated, challenges mounted. In 2024, founder Jonathan Yaney was replaced by COO David Wren, signaling a shift from bold vision to business execution. Investors wanted results, and more funding. Building the full-scale launcher would cost hundreds of millions more. Technical hurdles loomed, scaling up the machine, perfecting the release and making satellites survive 10,000 Gs. Meanwhile, SpaceX's reusable Falcon 9 rockets were dominating the market, offering cheap, reliable rides to orbit. Why risk a new, unproven system when you could book a spot on a Falcon 9 for a fraction of the cost? The economic window for disruption was closing fast. SpinLaunch faced a classic catch-22. It needed customers to fund development, but customers wanted a proven system first. Even with new leadership and fresh funding, doubts grew about whether the dream could survive. The pressure was on. In December 2024, SpinLaunch halted its Orbital Accelerator project. The dream of a giant electric slingshot to space was grounded, at least for now. The technical challenges were immense, scaling up, ensuring reliability, and building satellites tough enough for the ride. Market realities were even harsher. SpaceX's rideshare program made launches cheap and routine, leaving little room for risky newcomers. Investors grew wary. Customers wanted a proven track record. Even interest from the US Department of Defense wasn't enough to justify the cost. SpinLaunch's bold idea had run up against the hard limits of physics, economics, and timing. The project was shelved, a casualty of the brutal space industry. The dream for now was over. Was SpinLaunch a failure? Not at all. It proved the value of daring to think differently, challenging the rocket status quo with a radical new approach. The knowledge gained about materials, high-speed mechanics, and rugged electronics will inspire future innovators. SpinLaunch's story is a lesson in timing, market forces, and the relentless push for progress. The dream of a kinetic launcher isn't dead, just dormant, waiting for new technology and new needs. Every bold attempt moves us forward, even if it doesn't reach orbit. SpinLaunch carried the baton for a while, bringing us closer to a future where space is truly accessible. The quest for the stars continues.